Okay, now let's talk about limits of size. So all dimensions on your part, excluding some basic dimensions, must include a tolerance. Okay? Must include a tolerance. That will be a reference dimension we have in parentheses. Now, this tolerance is the amount of variation that's allowed. Because nobody's perfect. You can't just say, well, it's going to be 5 and say, well, it needs to be 5. Because if you go down to an atomic scale, well, everything is a bunch of circles, and so where are you defining that 5 from? And there are going to be little variations there. There's going to be one extra atom here, might be missing an atom somewhere else. So obviously, it's not going to be perfect. There's going to be variation. And usually, it's much bigger than that atomic scale variation. So that tolerance is going to have a maximum and minimum allowed size based on this variation. And as long as you have a part that is within that size boundary, so maybe this is the smallest it could be, and this is the biggest, well, then it passes. If it's too big or too small, it fails. Now, there's various ways we can show this. One way is to specify what the maximum or minimum size is by giving two different dimensions. These are called limit dimensions. Now, in this case, the maximum is always written above the minimum. Now, if it's in a note, then the minimum limit will precede the larger. It'll be separated by a dash. So this is for maximum right here. This is when they're both shown. And if you have it in a note somewhere else, you know, tolerance 0.5 to 0.7. That's just saying what's going to be with some note somewhere else. Don't see this quite as often as you will see this. Now, we might be more familiar, though, is what a plus and minus tolerance. What this does is, for one, it tells you, okay, what is it supposed to be like? What's the perfect number? In this case, it's 0.876. You didn't know that from the previous one. It just said, here's where it can go. But never telling what its like perfect application was going to be. And then you have what's called a bilateral tolerance. So it allows variation in both directions. You can just say plus minus 0.001. That works. But in this case, we're actually breaking it and saying, okay, we have 0.002 greater is fine, or 0.001 less is fine. Unilateral tolerance, right here, you can see that there's only tolerance in one direction. It can get smaller, it can't get bigger. And this does happen. There are cases where you, under no circumstance, can be bigger, but you can make it smaller, which for this feature at least would be fine. Because if they made it too big, they could always just trim it down. That's the nice thing. Usually for holes, a bigger hole is still typically fine because usually you get increased tolerance. And for pegs, a smaller peg is usually fine when it comes to making things together. So in most cases, there's a way to fix things. And that's actually going to bring us back to our max material condition a little bit later. I'm not going to talk about that today, but that will come in fairly soon. There are other cases where you'll only have a single dimension. In this case, right here, it's saying that that fillet right there, which we can't see as well, but I'll just go ahead and zoom in on it like this. So that's that area, zooming in. And it has a maximum of radius of 0.03. Now, since this is a fillet, it's a rounded corner, what do you think the smallest fillet that could be possible would be? Well, a radius of 0, which would be just a straight line. So obviously there are no negative fillets. Like, you can't have a negative curve. And so eventually it's going to have a controlled minimum. So that's why we only have to have a single limit. Other cases where we might have that is if we have like a pipe and there's knurling on it, and it might be like this, and it says, okay, we want at least a minimum of 0.5 inches. What would be the maximum? Well, the maximum would be the full pipe. So if they manage to do on the full pipe, okay, that works. But that's what's controlling it. There is a limit, and we don't need to specify it because the limit is obvious. Okay, that's it for this time. What did we talk about? Bilateral tolerances, that's plus some number, minus some number. Unilateral tolerance, where we have one of them that's 0. And the limit dimensions, where we have two numbers, which tells us what it's going to be. So I hope this helps you, and I'll see you all next. Actually, I reversed that, right? So I did it wrong. 0.999, 0.997. There you go. I hope this helps you, and I'll see you all next time. Thanks for listening. Bye-bye.